Hi everyone, welcome back to my channel, Numerics with Nadia. In today's lesson, we're going to go over the difference between terminating and repeating decimals. If you have not yet watched last week's video on how to convert fractions to decimals, I would really recommend watching that video first because we're going to go over that concept again in this video while also identifying and distinguishing between terminating and repeating decimals. So to start off today's lesson, let's start out with defining what a terminating decimal is and what a repeating decimal is. So a terminating decimal is a decimal that finishes on its own. So when we do either our long division step or the shortcut method, it will terminate and finish on its own. On the other hand, though, a repeating decimal, or we can also call it a reoccurring decimal, are decimals that repeat the same number or pattern with no end. So it's going to continue repeating that either single number or pattern forever. So let's think about what these would look like. What would a visual example of these be? A visual example of a terminating decimal would look like something like 0.2. So that is a decimal that terminates and finishes on its own, right? On the other hand, an example of a repeating decimal could be something like 0.33333. It's going to continue forever, right? The way in which we would notate this 3 continuing on forever is a key part of distinguishing a repeating decimal. What we do is rewrite the 0.3 and then the bar would be over the part that's repeating. So in this example, only the 3 is repeating. So the bar would go above the 3 to show that this is a repeating decimal and to show which part of the decimal is the repeating pattern. All right, so now that we've shown what a visual example of a terminating and a repeating decimal are, let's go through some additional examples of how to convert a fraction to a decimal. And then after that point, we're going to see, is this decimal a terminating or repeating decimal? So we're going to convert and then classify it. For number 1, we have 4/9. And for this one, we can't multiply the 9 to turn it into a 100, so we're going to do the long division method. We're going to have our 9 outside and our 4 inside. We know that 9 doesn't go into 4, but 9 goes into 40. 9 times 4 gives us 36. When I subtract 40 and 36, I get 4 as my remainder. If I bring down a 0, I'm left with 40. If I see how many times 9 goes into 40, it's 4 again, right? 9 times 4 is 36. If I subtract, 40 minus 36 will again give me just 4. And if I bring down another 0, it's looking like we're repeating, right? If I bring down the 0 again, okay, we have 40. 9 goes into 40 4 times, and we're going to get the same thing, right? 9 times 4 is 36. 40 minus 36 is 4. And this process is going to continue to repeat. If I bring down another 0, just to be sure, we know 9 times 4 again will give me 36. And then we get the same remainder each and every time. So in this case, we have a repeating decimal. And what is repeating? The 4 is repeating. So we would write this as 0.4 with a bar over the 4, and we would classify this as a repeating decimal. All right, you guys, one quick note before we move on to the next one. You want to go out at least 3 to 4 decimal points before officially classifying a decimal as a repeating decimal. So that's why we went out 3 decimal places for number 1. Let's try number 2 now. For number 2, we have 1/8. We are not able to multiply that 8 by anything to get it to be a 100 to use the shortcut method. So we'll just do long division. 8 doesn't go into 1, but 8 goes into 10 one time, right? 8 times 1 is 8. When we subtract 10 minus 8, we get 2. If I bring down the 0, how many times does 8 go into 20? That would be twice, right? 8 times 2 is 16. When we subtract 20 minus 16, we get 4. Bring down that last 0. How many times does 8 go into 40? Well, that would just be 5, right? 8 times 5 is 40. That would 0 us out. And number 2 would be 0.125 for our answer. And in this case, this would be a terminating decimal, right? It is terminating, it is ending on its own. All right, you guys, let's move on to number 3 now. For number 3, we have 3 over 11. Again, this is not a denominator where we can use the shortcut method, so we're going to do long division. 11 goes on the outside of the bar, and 3 will go on the inside. 11 doesn't go into 3, so we write our 0 in our decimal point. 11 goes into 30 twice, right? 11 times 2 is 22. 30 minus 22 gives us 8. We bring down the 0. 11 goes into 87 times. 7 times 11 is 77. 80 minus 77 is 3. We'll bring down another 0. 11 goes into 30 twice, right? 11 times 2 is 22. 30 minus 22 will give me 8. We bring down the 0. 11 goes into 87 times, right? 80 minus 77 gives me 3. So it looks like we're repeating here, right? The 2 and the 7 and the 2 and the 7 seem to be repeating. So our answer would just be 0.27 with a bar over the 2 and the 7, since the 2, 7 is the pattern that's repeating. And we would classify number 3 as a repeating decimal. All right, let's move on to number 4 now. For number 4, we have 5/8. We're going to have to use long division again. 8 goes on the outside, 5 goes on the inside of the bar. 8 does not go into 5, so we'll draw our 0 in our decimal point. 8 goes into 50 6 times, right? 8 times 6 is 48. When we subtract 50 and 48, we get 2. Bring down the 0. 8 goes into 20 2 times, right? 8 times 2 gives me 16. 20 minus 16 will leave me with a 4. We'll bring down another 0. And 8 goes into 40 5 times, right? 8 times 5 is 40. So we will subtract by 40. 40 minus 40 will 0 us out. And our answer for number 4 will be 0.625. And this would be a terminating decimal, right? Because it is ending on its own and nothing is repeating here. Now we'll move on to number 5. For number 5, we have 1/12. So again, we'll use the long division method. 12 will go on the outside of the bar, and 1 will go on the inside of the bar. We know that 12 does not go into 1, right? So we can draw our 0 and our decimal point. 12 also does not go into 10, so we can draw another 0. But 12 goes into 100, right? How many times does 12 go into 100? 12 goes into 100 8 times. And for anyone who does not remember their 12's times tables, we'll do a little multiplication on the side here. 12 times 8 gives us 96. So 100 minus 96 is 4. We'll bring down a 0. 12 goes into 40 3 times, right? 12 times 3 gives us 36. So we'll subtract 36 from 40. 40 minus 36 gives us 4. We'll bring down a 0 again. 12 goes into 40 3 times, right? 12 times 3 is 36. Subtract out from 36, we'll get a 4 left over again. If we bring down another 0, it's again going to be 40. 12 goes into 40 3 times, right? 12 times 3 gives us 36. We'll have a 4 left over again. And we can tell now that that 3 is going to repeat forever. So our answer for number 5 is going to be 0.83, but the bar is only going to go over the 3 because that is the pattern that is repeating. And we would obviously classify our answer as a repeating decimal, right? All right, you guys, thank you so much for watching. I hope you enjoyed today's video. Please subscribe if you aren't already. Feel free to like and comment on this video if you have any other topics you'd like to see a video on, and I will see you guys next time.